Welcome to homework.
Using the Van Hoff factors in table 14.7, let's calculate each colligative property. For A, we're asked to calculate the melting point of a 0.1 molal iron 3 chloride solution. So we'll have to calculate the freezing point depression, which is equal to the Van Hoff constant, the freezing point depression constant times the molality, and the freezing point depression constant here is equal to 3.4. The freezing point depression constant is 1.86 degrees Celsius per molal, and the molality is 0.100 molal. And working this out, we find that the delta TF is equal to 0.63 degrees Celsius. So the freezing point is equal to 0 minus 0.63, or 0 degrees Celsius minus 0.63 degrees Celsius. And we'll find our freezing point is negative 0.63 degrees Celsius for the solution described in A. For B, the osmotic pressure of a 0.085 molar potassium sulfate solution at 298 Kelvin. So our formula for osmotic pressure, pi is our osmotic pressure, is equal to the Van Hoff constant, the molarity times the ideal gas constant times the temperature. So our Van Hoff constant, looking it up, for potassium sulfate is 2.6, and our molarity is 0.085 molar. Ideal gas constant is 0.08206 liters atmospheres per mole Kelvin, and our temperature is 298 Kelvin. And calculating the osmotic pressure, we find that that is equal to 5.40 atmospheres. This would be the osmotic pressure for solution B. And for C, the boiling point of a 1.22% by mass magnesium chloride solution. So we'll need to calculate the boiling point elevation. And so the mass of water, well, we have a 1.22% by mass magnesium, 1.22% by mass magnesium chloride solution. That's going to be aqueous. So the mass of water, we'll assume we have 100 grams. So this would be 100 grams minus 1.22 grams, and this would be equal to 98.78 grams, or 0.09878 kilograms. And the moles of the magnesium chloride is equal to 1.22 grams of the magnesium chloride multiplied by the molar mass of 95.211 grams of magnesium chloride in 1 mole of magnesium chloride, and this would yield 0.0128 moles of magnesium chloride. So now we'll calculate the molality of the magnesium chloride solution, which is 0.0128 moles of magnesium chloride divided by the mass of water in kilograms, 0.09878 kilograms of H2O, and therefore our molality is 0.1297 molal. And now we can calculate our boiling point elevation, which is IKBM. The Van Hoff factor is equal to 2.7. The boiling point elevation constant is 0.512 degrees Celsius per molal, and our molality is 0.1297 molal. Our delta TB is equal to 0.18 degrees Celsius. Therefore, our boiling point is equal to 100 degrees Celsius plus 0.18 degrees Celsius, and it's equal to 100.18 degrees Celsius would be the boiling point elevation.